Hello everybody, so welcome to this new lecture. So in this lecture, this is an analysis of a case study of a change that we really put in production in Pharo. And the idea is to show how we introduce delegation of behavior to obtain a more modular system. So what we will see in this lecture, we will look at the class definition printer, check the design in Pharo, and it will help us also to think modular. So let's look at the context and the challenges that we faced. One of the key questions in Pharo was how to support various class definition format and in a modular way. So this means without having to check everywhere, everything. So when I said various format, in fact, we have the old squeak syntax format, the old Pharo definition, and the fluid syntax that we saw in the fluid lecture. In addition, so we have various formats, but we have also various objects. So this means that we have class, metaclass, traits, the class side of traits. And the key question there, this is how do we control this complexity? Because, for example, slot, first class instance variable, should not be displayed in all Pharo nor in squeak, but they should be displayed in the fluid syntax. And the point of all this is how can we do that without having checks everywhere? And in addition, can we have a modular system where we can remove one definition at any time? So let's see how it was done before. So in Pharo 7 or 8, in fact, there was a first introduction of slots, and it was hacked, basically. It was working, but it was a bit hackish. So you see, so for example, in the definition of the class description, so class description is the super class of class and metaclass. We had a method that was called definition, and then it was checking, oh, do I need to have a slot, and should I show the slot? If this is the case, then I will have a definition with slot, else I have a definition without slot. And guess what? The same in metaclass, we have checks there. And as you can imagine, we have also checks inside, for example, the class template. So this means that when you were defining a new class, the system would do again this condition to produce the correct one here with slot and the other one with instance variable names. So this means that you imagine that plus fluid in the middle, okay, it was not working, it was not scaling. So now what I suggest is that take 5 minutes, press pause on this video, take 5 minutes to see how you would solve it. So what is the solution? So what you saw is that at the beginning of the lecture, we already said that sending a message is making a choice, but to be able to send a message, we needed class so that we could have instances of different classes where we could send messages, and those messages would select different methods. So this is what we will do here. In fact, we will create a class hierarchy of printers where we have, for example, the fluid class definition printer, the legacy class definition printer, and the whole Pharo class definition printer. And basically, this is a kind of strategy, and the class will delegate to the printer for its own printing. So we will have a system where we have the class, or you will see this is a bit more complex, but let's think that this is simple like that now, where we have this hierarchy of printer here. And then we delegate, and at runtime, depending on the printer that we select, we will get the correct one. So let's go a bit in details. What is it? So if you imagine, so a tool, for example, here, will send a message, and we will execute this method, definition string. So what the definition string will do is that it will create an adequate printer, an instance of these three classes, and then it will ask, oh, can you give me the definition string? And each of these class will return, oh yes, for example, the legacy definition printer knows how to define, how to print a class, how to print a metaclass, how to print a trait. The same way, the fluid class definition printer knows how to print a class, a metaclass, a trait, and so on. And what you see is that here, basically, the definition string is first creating a printer. So this printer will return one of these instances, and then we send the definition string. The definition string, this is not written on the diagram, will call the corresponding string methods that we have here. We will see that in a moment. So basically, this is what I just said. So we have two methods here, the definition string methods that will return the actual string. And to do that, it will first create an instance of a printer calling these methods. And these methods basically said, okay, given this entity, I want to have a printer for this entity. Since class description is the root of a hierarchy, you will see that we will have here potentially self is a class or a meta class. It's also a trait. So this is a variation point that we will see later. And once I have this printer, I just send the printer the definition string to this printer. So let's step back. A printer knows how to print a class, a meta class, a trait. So let's look at this to make it more concrete. For example, the fluid class printer will know how to print a class like that, a meta class like this. And here you see, for example, the class definition. It creates a stream, and then it will check if this is a null superclass. It will put nil. Then after, it will compose the message like that, and then it will check the slots and things. And finally, create the package. For the meta class definition, this is the same logic, but to really produce a different setup. For example, what is interesting is that for the old Pharo format, we don't want to display slots. We decided that they should not be displayed to simplify the system. And here, this means that this is this printer that encapsulates this logic. So here he said, okay, given a class that I should print, I will ask the class, do you need a slot definition? If you don't need it, I will just print a basic definition. If you do it, then I will create a different printer and ask this different printer for the definition. So this means that here, this is this printer that encapsulate and control the logic and not the tools or anything. So now what we see is that for the class template, the logic is much simpler. We said, okay, I want a class definition. I want to have the compact template, for example, and that's it. And I give the name, and I get the printer depending on in which format I am. I don't have to do checks here. So if we see, we have one format, one printer. A printer can support multiple related features, so like expansion. So I did not explain what is expansion, but if you have a partial class definition and you want to see all the parameters that you want, you could say, oh, please, class definition, can you expand and show me all the possible variations that I have? The template, the default template that you see in the debugger, and the actual class printing. And there is a support also of reuse within the hierarchy of the printer, and the possibility to have a default way of managing printers. For example, if I have a problem, the legacy will just say, no, I don't know how to do it. You have to use a fluid printer. And like that, it supports also the evolution of the domain and the language from that perspective. So, but there is more. In fact, we have more challenges than that. So this means that for now, we have multiple printers, but in fact, we should support different entities printed by different printers. So at the end, we will have class description, which has meta class, class, and potentially traits. I don't remember exactly if this is that, but I think that this is like that. And the printer. So here I have another hierarchy of printer here. And the question is, I want, for example, to be able to print a class in the old format, or a class in the fluid format, or a trait in the old format. So I have all the combination. So how do we do that? I think that normally you should have a really an idea now. This is like if we need to select one method based on two things. So the solution here, this is double dispatch. Let's look at it. So you remember, so the definition string was basically called, and what we see is that here definition string will ask, we said, oh, in fact, I will not decide, I will just ask the class, hey class, can you give me the definition string for myself, because I am a printer, so if I am fluid, because each printer knows how to print things. So this printer, they know how to print meta class, class, traits, class, meta class, traits, and so on. But I don't know when to invoke these methods. So now what I do, I just said, okay, can you just, I ask the class egg or the entity, because this entity can be a class, a meta class, or a trait. I said entity or for class here, can you give me the correct one? And then I will have this dispatch. So when I am a class, I will ask the class, oh, display me as a class. When this is a meta class, I would say the printer, oh, there is a bug here. This is meta class. I should say meta class, can you, and when this is a trait, print me as a trait. So what you see is that we have a double dispatch. And in fact, this is exactly the same as in the visitor design pattern. So if you think that this is a visitor, for example, so this means that I am the object knowing how to do things. And here, class description, with my hierarchy, this is a bit like my composite. It's not really the idea of the composite, but in the visitor design pattern that we presented, we had a composite. So this means that this visitor will visit this structure using double dispatch. And the key point, this is in these methods where you see, so this is not the argument that we dispatch on, but we dispatch on an instance variable that has been set before. So here you have all the code, basically, and you see, okay, I will select the correct definition each time. You see here I even show the threaded meta class because this is one case that I didn't show you, but this is exactly the same all the time, the same design. The printer, the entity is requested, and it has the print. It say to the printer, yes, I want to be displayed as a class, as a trait, or as a threaded meta class. But there is more. In fact, we don't want to have direct references to printer in all the code. Why? Because we want to be able to remove printers. In fact, in Pharo, we don't want to have 20 different class definition. We want to have one that is fluid. We just want to make sure that we have package that can be loaded by our client so that they can manage all code if they want. So the idea, this is really that it should be optional. So the design here, and you saw it a bit in the previous slide, this is that we only reference the superclass that has as a factory. So let's look at it. So I have the class definition printer, which is the root of the hierarchy. You see it has an instance variable for the knowing on what class it should print, and some shared variable to be able to know what we should show or not, depending on the system. And then the new here, the new method will check, oh, if I am configured to display information in fluid, then I will return an instance of my subclass that is the fluid class definition printer. Else, I will return the old Pharo version. So this means that basically what you have is that you have your hierarchy. All the clients here will only refer to this guy and never to the instance. But this guy here, the class definition printer, will create instances of its subclass, either this one or that one, or even when we ask the legacy, it will return an instance of the legacy. And this means that like that, I can just plug or unplug, for example, I can remove the legacy if I want from the system. So for example, how this is done, the old definition, I would say, okay, class definition printer legacy for self class definition string, it will return me the definition of the class as in the old version. But this means that I can remove these methods and I have no problem. So as a conclusion, this is another example of how we can dispatch on object to avoid condition. And what it adds also the idea of how do we manage the creation of the correct object. If you want to know more, what I suggest is that you really look at the Pharo code because this is in production. And it took us some time to really get it nicely done. And this is nice because it already supports these three different class definitions. And it is helping us to migrate where we want over the different version of Pharo.